at machine learning library. So today's session, I'm going to start with pandas. I will introduce the data structure users in pandas, as well as so if you use pandas, it's well suited for analyzing your data set, especially you work with machine learning and other applications. The represented data in pandas would be very helpful for you to starting from basic analytics to advanced analytics as well, because pandas supports various manipulations in data. Right. And the other one is pandas is also built on top of NumPy. So the whatever the material that we have covered in NumPy also applies here as well. So you will see I'm making use of both. So let me start importing libraries for this part. So I will use NumPy because it needs this, because and pandas built on top of NumPy. Okay, I think. Right. So when I created it, actually, I put it in the same place. So maybe, yeah. So I will take that back. Okay, so this is where we were. Right, okay. The first one is NumPy. Anyway, we need it, and we are going to use pandas data frames. And as a short norm, it's a commonly used PD. And commonly, when I work with pandas, you might see I'm frequently using these two libraries. Okay, in NumPy we created arrays, right? Yes, and in NumPy arrays we discuss about the 2D and also 1D and 2D arrays, we call it. In pandas we use the term series and data frames. So that's something that we need to get familiar with. So we will learn how to create series, right? This is one-dimensional ones, 1D you can see, right? And then data frames. We call data frames. It's 2D. So that's something that we use. So when I say series, remember it's one-dimensional ones we discuss. When you talk data frames, it's 2 dimensions. So let me create a simple series. The command is simply we can use pd dot series. So this is what we use the method. If you need the help, just type help pd dot series, you get the information. And then you can provide a list like data. So for example, if I want to store, let's say 4 numbers, 1, 2, and 4, 5, this is how we may use. So since it's a series, let me put this as S1. So this is how you may define, and then simply you can use print. So the same things that we have discussed is also applicable here as well. So hopefully this is what you will get. Note that it will create a series with the indexes. So you can see indexes here from 0 to 3. Right? So for example, commands that actually you can use to check the size, shape, and so on. So we can say is one.shape. So this was available in NumPy as well. It says 4 comma, yes. And then let me check size as well. Yes. Yes, we have size as well, which gives you a number of elements. That's 4. Again, it was available in NumPy. And then apart from that, we can talk about the index as well, right? Which gives you the index. It says as a range index. So simply we have 0, 1, 2, 3. So it says start 0 to 4 with the step is 1, which is 1 to 3, right? 0, sorry, It's 1 to 3, 0 to 3. Yeah. Okay, this is simply how we may create a series. Okay, now what we have used so far is numerical index, isn't it? Like this is possible with the NumPy arrays as well. But of course, then you can use labels as well, right? And especially when it comes to work with the data, the labeling is important because we can't remember always the index value, and it's very difficult to work with data. So therefore, let me explain how we can have index as well. So ideally, right now we have a numerical index here. So let me explain how you put into a label as well. So same thing I'm going to extend. So I'm going to take a copy of this. But before that, can you confirm whether you have finished up to this point? Done? Finish up to this point? Thanks. So the next part, what I'm going to do is the same thing as I told you earlier. I'm going to make it, this is S2, but the difference is I'm going to create a series with index values. We are going to use some labels here. What I mean here is instead of saying, okay, you need to access the first value with the index 0, we will just put a label. So I'm going to have an index. So this can be put as a put it as a list. So I will have the first one as A, B, C, D. It's like this is like attribute names in a data set, right? So, but you we have one. So the difference that you will get it here is, right, when you print it now, instead of numbers, you see the labels. And whenever you want to access it, you can use just a label. For example, if you want the first one in previous, it's the S10, right? The first value. But in here, you just say the label. Yes, you will get 1, 1. So the ideally, so instead of working with the indexes, so you have a flexibility of accessing the element with this label, which is what we needed, especially in data analytics in data science applications. So we need to, directly access the data item. So that's the way to go. Right, good. Shall we move on to the next one? Right, done. So let's move to the next one then. So I'm going to now introduce data frames. We can go to 2D ones. Creation of data frames. For data frame. Okay, now can you tell me how to create a three by three random matrix? Yes. How do you create 3 by 3 random matrix? If you use NumPy, I hope you remember we discussed creating random values. We have used rand, randin, and randint, right? We discussed three methods. So I'm going to use randn, normally distributed values, and then we put 3 by 3. So what happens here? If you remember from our previous sessions, we just create a 3 by 3 matrix, which will with normally distributed random values. So now we are going to create a data frame based on that. So let me put this as data frame 1. I'm going to say df1, and the command will be pd dot data frame. So make a note of this data frame. Okay, this is what we are going to use, right? So if you just put this, see what will happen. And let's print data frame 1, or you can just say df1. Even just df1 is enough. Maybe df1 would be enough, and it's more, you can see clearly how it look here, right? So one thing to note, that everything will be in numerical indexes. That means a column as well as rows. Okay. Now, usually, if you think this as a data set, we need to have the labels, right? So let me explain how we can do that. So I'm going to extend the same. So I'm copy pasting this one so that we are not going to miss. So the command is we can define something called columns, and we can give the labels. So in our case, let's say I'm going to use capital letters A, B, C. This is one way to define them, right? And this time, if you run this, notice that the columns are labeled with ABC. This is one way to do this. Or else, the other way to do this is the columns you can define as a list, right? And then you can provide the letters as a string value. So I will show you. But this is common. So this is the common way to, creating a data frame, and then you provide the column labels. Okay. So there was a request to explain what a data frame is. So if you ask me what data frame is a two-dimensional data structure where you have rows and columns with label. In usually NumPy, we have all numeric indexes, but in data frames gives you a flexibility. You can have labels on the numbers. At the same time, it supports various data manipulation techniques. So that's what we are learning here. So you can think simply as another data structure like list, like NumPy arrays. In data frames, you will get a new set of tools, methods to manipulate data easily. So that's why we put data frames. And later today, I will also explain, working with the various different types of data. Like you can create data frames easily with CSV files, Excel files, PDF files. And even you can get data from the web directly as data frames. So that's the use of data frames. So hope you got this idea why we need data frames. Okay. But simply it's like simple, list of lists that we have discussed, or a NumPy array, 2D array, but you have more methods, more ways to manipulate. So that's why data frames are used. And especially when you work with various different types of other data formats, conversion will be very easy, because converting into list of list or NumPy might be a bit difficult compared to data frames. Okay. So with that said, let's move on to the next one. So we discuss the creation of columns, right? And then, yeah, one more thing, the same thing I'm going to do as a list. So I said there are two ways of doing this. So the next one, same thing. This part you can automatically generate using, this list can be automatically used with the list method, where you can list the columns. In this case, we have it as ABC. So you have a string of ABC where you convert this to a list and you can replace. So same thing, but in a slightly different way of doing this. Okay, now that we have learned about how to create a data frame and also make a, column labels, you can actually apply the same things that we have discussed in with the NumPy arrays as well as series. That means you can get the shape, you can get the size, the index, the columns, and so on, right? So let me put that information now. So let's start with, so we said it's df1, right? So I'm going to say, okay, df1. So make sure that you use print here. Otherwise, df1, okay, shape will give you the shape, number of rows and the columns. Then df1 size. Then it will give you the number of elements. df1 index, the index information, right? In this particular case, index means the column, row labels. Then you have df1 columns. So you can see here. So the shape is 3 by 3. You have 3 rows and 3 columns. The size is you have 9 elements. Index is the rows. In this case, it goes from 0 to 0, 1, 2. So start is 0, stop is 3, and step is 1. The columns, the labels, it's ABC. So that's the information we get. Right. One last thing. If you want to know what kind of data types you have, simply go to info. So similar to this one, there's a method called df1.info. So let me take this. If I'm going fast, just let me know. I can go back to the code. So don't, hesitate to contact me. So let me put df1.info, which will give you a complete information about the data frame, right? So it will tell you that it's a data frame. So let me show you when you run it. Yes. Now you can say that it says that this is a data frame. And it shows you the range index 3, the row indexes, then column. And in this one, it will go into more information. Each column, whether you have null values or not, and also the data type, right? And it will show memory usage and so on. So everything is given in data frame info. Right. Any questions up to this point? Right. Shall we move on? Right. Let's explain viewing in pandas. What I mean by view is, for example, for a small data set, you can view everything in one single shot. But let's say you have a large data set, and if you want to view it, you might not be able to view everything. So I think automatically you will get the code here nowadays. It says head is you can view the first five rows in a data set. So let's create a new data frame. I'm going to say data frame 2. In this one, I'm going to create a data frame. I'm going to use np.random.ran n. This time I'm going to say 100,3. So what happens here? You have 100 rows and 3 columns. And let me put columns as a list of short to type, so that I will put it this A, B, C, right? And now if you try DF2, right? So you will get like this, because you can't visualize everything. It'll show you only part of the data. But ideally, there are some methods that you can actually get. So for example, you can say df2.head, which gives you the first 5 rows. So head will give you the first 5 rows, right? And in print in this manner. So you will get first 5 rows. So like I said, if you want to know more about this command, so hopefully let's see whether this is working. pd.head should work. Is it? Oh, no. Pandas head? No. Data frame. Okay. You can check the documentation. The command is slightly different, so sorry about that. So you have to say pd data frame. So yes, and then what we need is head. Sorry about that. Yeah. So you can notice here, if you look at the help function, it says head self n, it's integer 5. So you return the first n rows, it's 5. So what it means, we can go to the next one. So we can say head 10, right? Exactly. So some of you have already done. So we have df2.head 10. So I just want to show you the help. So I hope now you got the idea, right? So that's how we can get, head. Good. The next one, few things. So getting header, similar to that, you can try tail as well. If you are familiar with the Unix or Linux, head and tail is commands that we can use to check first rows and the tail row, the last rows. So for example, df2.tail would give you the last 5 rows. So in this manner, you can actually, get or view a data set. Because if you can't view everything in this frame, right? And by combining head and tail, you should be able to see exactly what you need to see anywhere in the data set, right? So with that said, right, let me give you few information about the transformations. So we looked at weaving head and tail. In case if you want to convert this to NumPy, it's easy. So for example, we can convert this into a NumPy array. So for example, let me say df3. I'm going to use df2.head. We know what happens. It'll take the first 5 rows and put into df3. And then if I convert df3 to NumPy array, it's called to NumPy. So this will convert data frame to NumPy array. Some places we need to do this, right? So for example, if the code supports only NumPy arrays, so we need to convert to data frame NumPy. So if you run this, so the output will be a simple array like this. Right. So now I think we discuss about how to view, how to convert in NumPy. More information. So for example, the next one that I would like to discuss is getting information about the data. So assume that this is a data set. We have 100 rows, right, in DF2, and we have 3 columns. So let's say we want to see, we need to characteristics of the data. Simply type df2 describe. So if you say df2 describe, it'll give you information about the data frame. For example, so if I do this for my data set, it will tell me how many records we have. So we have 3 columns, we have 100 each. Provides mean values for each of these 3 columns, standard deviations, mean values, max values, quartiles. So 25% quartile, 50% quartile, and 75 quartile, and so on. So simply you can get the details about your columns, right? Simply typing the describe method. Right. Now that we have looked at the statistics, so let me show you some other processes. So for example, you can get the transpose of this. So the right now is we have 100 by 3, and then you can get the transpose like in matrices. So the capital T, the same thing we have learned in the NumPy as well. So if you do that, this becomes 3 into 100. So now you can see the columns are comes as the rows, and then the rows comes as columns. Okay, there was a question on visualization of this one. And then Gavindu, can you tell me like whether I have explained this in NumPy? Did I explain 3D graphics with NumPy last time? Okay, right. Then I come to this point as well. Yeah. So, but if I until others are working. If you just simple idea of how they put it into visualization, simply they will divide the XY's Z axis into what we call small, um, mesh-like structure. And that mesh is used to, plot, for example, 3D, especially surfaces. So you can have a control of mesh size, and based on the mesh size, you will get, different quality of your 3D graphics. So I'll come to that point. Yeah, good point. And then maybe I'll separately talk about especially how 3D graphics or 3D graphs can be developed, and how do you control over the quality of the graphic as well. Right. So we were discussing about the transpose operation, and then let's move on. Right. Let me talk about the sorting. Right. Now, data sorting is again another interesting point. So, for example, if you want to now the rows I arrange in the descending order, ascending order from 0 to 99, the index value. So, for example, DF2, if I show you, it's look like this. So it goes from row number 0 to row number 99. We have 100 rows. So let's say we need to sort, but if you want to sort this based on, so let's say I want to sort, you say index, right? You say sort index, and then you are actually getting that ascending false. So ascending false means, right, it's descending, right? So it's a flag. You can check in the help. Ideally, it's true. Ascending is true. But if you say false, it's ordering descending. So you get the 100th row as the first one. So this is one way that you can actually sort. Now, similar to that, if you ask me, right, if you want to do this in the column wise, how do you do that, right? Then I hope you remember the axis values we have used. So you have to define which axis you are going to use. So maybe I can go to this help and we'll see. So that information should be available. Oh, okay, now you can see here. So it says def sort, we have axis, and the axis is 0. So when you say axis is 0, that you work with the rows. So that means ideally, if you need to change that, you have to set axis to 1. And then you say ascending 4, same thing. So what I'm going to do, slight change of this one. So for example, same thing, but let's say I want to perform, I will say axis is 1. So in that way, what will happen? Instead of rows, we sort descending order the columns. So we had A, B, C. Now you see we have C, B, A. Hope you have understood the idea of sorting here. That means we have sorted rows in descending order, columns in descending order. But about if you want to sort based on a particular value, right? That you have to provide. So if you go to sort, but this time not based on the index, let's say based on the value. So values within this. So there's a method called sort values, and then you have to provide which based on which column that you need to sort. So shall we move to that one then? Right, the next command that I'm going to discuss, I'm going to use df2 sort values. Check that one. And if you need, let's say you want to sort based on the values in B, you can just put B. So let me show you, right? Sometimes we need to, sort based on the values. Sorry, I will, copy the same. Oh, no, this is new. So what I want to type is, I want to sort based on the values. And yeah, So maybe we can put it here. I want to sort by the values. So the command is sort values, and you have to say which column. So if you say B, you will notice that now the data is sorted based on the column B, and this is how it looked like to me. So the number 48 is the first one, which you have the smallest value. So number 0, that is the first row, you have the highest value. Right. Yes. Can you confirm whether you have? Okay. So in this one, we discuss how to sort based on the values, and we specify the column, and you can see the smallest value is in column, sorry, row number 48. The index is 47, it's 48. And the highest value is in row index 0, which is the first row. Right. So the next one, I want to explain how you can ranks. The ranks are again useful like in machine learning application, right? For example, let's say I have classification accuracies and I want to rank those accuracies, right? So the rank is very, very helpful. And what happens here, which says rank, it rank all these values. So for example, we know the row number 1 in B, the rank is 100, right? Because it's the highest value from the previous one. Yes. Have you noticed here? Column B. Yes, this is the highest value. So the rank is 100. The lowest value get the rank number 1. And then this is 100. So likewise, the value in A here is rank number 63. And this is 26. So the ranking. So each and every value respect to that particular column, it will rank. So for example, if you take, yeah, so what is it? So 2, for example, if you take row 3 here, the rank here is 6. If you check the lowest value is 6. And here you can see that is 4. So you can notice that the ranking information provided. Right. So that's about viewing the data in various ways, right? Now I'm going to, talk about how you may, make some selection, right? So let's move on to the next part. I'm going to talk about selection here. Okay, selection. So you have a data set. You have to, we need to select data set, part of the data set. We need to select by rows. We have to select by columns and so on. Right. The two ways that we can do is this. Again, very important. Let's say I have 3 rows in DF2, right? We have A, we have B, we have C. So let's say I want to select the first one. So 2 ways we can use df2.a. So this is one way to select the first column. Yes, one way. This is method 1. You can simply say df2.a, or else we have say df2 within square brackets, we say a. So both ways I'm using, and you might see in the code as well. So understanding this is important. So we simply, this means that we are selecting, column A. Right. Okay. So let me put the second one. You can say df2. You can say A. So both techniques works. So make a note of selection of columns. Okay, good. Then rows, right? I hope you remember the slice operation. Remember the slice operation? So let's say if you want to select the first 3 rows, so we can say df2. We can say start and stop. We can say first 3 rows. So you can do like this. So 0 to 3, we have 0, 1, 2. You say first three rows. The shorter version of this, I think we have discussed this. You can say colon 3. So which will give you the first three rows. Yes, agree? Right. Okay. So slice operation, I hope you remember, and this is very, very interesting one. And for example, the use of this is very, very important that, for example, if you want to select, and if you want to ignore, let's say the first, okay, let's say something like this. So you want to view from the second row. So that means you want to ignore the first row. So let's see how you are going to do this. So the idea is we have to specify starting value. So ideally we have to say starting value is second row, that is 1, and colon maybe the last element, so that you don't have to specify. I think we have discussed this earlier as well. So simply you can put 1 colon. So what happens, you will get, you ignore the first one, that is the index 0. It's ignored, and then you print. Again, very, very important. Let's say you have a data set where you have some label data in the first row. So this may be the way to select that part. Right. Anything in between, you can say start and stop. So let's say I want to select the middle elements, right? So for example, let's say I want to say, okay, DF2, I want to select starting from 50. So that means 51, right? To 55. So you can say 56. So you will select row number 51 to 55. So the index 50 to 54, right? So, and if you want, you can have a step as well. So let's say you need every other row, put a colon and put a 2. So which you can select every other row. That's also possible. So like this, so maybe I can use the same. So let's say I want to select between 0 to 51 every other row. So you can put it 2. So you select every other row, right? So that's slicing operation, which we have discussed earlier. So hope you are familiar with this one. Right. Right. Okay. Right. Next one. So in this one, what I want to discuss is how to access data. One way is using the location with the label and indexes, right? So there are a couple of methods that I want to discuss. So the commands that I am actually want to discuss is I want to discuss LOC, ILOC based on the index, .at and .iat. So I think help will give you, so if you say pd.dataframe, hope this will work, LOC. So see whether we can get that information. Yes. Right, you can see here. So the idea is just check the help. So primary based on the label based. So it's, you can say it's a label based. You can access. If you put I, then it's called index based. So sometimes you have to base on indexing. So, and then we have at. So simply in this one, you are particularly going to select the value based on the label. And then if you put I, then you are going to select, single value based on the position, the index. Right. So let me explain this. The first of all, if you're using a label, right? So let me put labels first. The right now, we don't have any label as such for DF2, but let me see. So first of all, yeah. So we will say DF2 dot LOC and then we put 0. This is called row label, right? Although it's a number, it's a label because we didn't put any label for that. You can do that. I will show you. We can use label, right? So in that case, we get something like this. It's ABC column. This is ABC column. These are the values extracted from this, right? So this might be helpful if you have both labels for rows and the column. That is possible. For example, yeah, maybe you can try this and then I will explain with another example. Yes, let me know when you are finished. Can have, if you're wondering why I have used label, but we put 0, it's because some cases you can have label for both rows and the column. So let me give an example. So I'm going to say data frame 4. I will say pd dot data frame. I'm going to create some random 3 by 3 matrix, random dot rand n. Right? I think we have discussed this earlier as well. So this will give you a 3 by 3 matrix. So let me use index. This is rows, and I'm going to use simple ABC. And then for columns, I will use capital ABC, right? So DF4 look like this. Ideally, so the rows also you have labels. And then if you want to access in this, what have we discussed, we can say DF, maybe I will write it here. We can say DF4, no, not this one. Yeah, we will say DF4.LOC, we'll say A, which you will get this, right? So that's where this is useful. So LOC is label based selection. So even you can select rows based on their labels, right? Could be even numbers as well. If you have numbers, you can just use the number. But ideally, the idea of LOC is you are going to make selection based on the labels. Right. Now, label index is okay, right? But let's say I want to access the first let's say, two columns from our data frame 2. So if you want to select the first two columns, right? Let's say select first two columns from DF2. Ideally, you should get the answer here. Yes, you get it now. df2.log and colon indicates that everything that you need. Yes. So this colon indicates that all the rows, but we are selecting the first two columns. So in that manner, you will notice that we are getting the first two columns based on the labels. So if you want to specify some middle row, maybe you can like this. Let me say df2.loc. Let's say I want to select from row number 10 to 15. Yes, 10 means 11, right? 11 to 15. And first two rows, this is how you may use it. So it's like you are selecting part of the data set. Yes, you got the point? Okay, so that's the label one. Then you can use the index by position. So let me explain the next one where we use a position at here. Right, so the selection by position. That means using index. So for example, you can say df2 dot ILOC. You can just take 3, right? So that is index 3, right? So you look at df2. So you select the index here by the position. It will tell you, it will give you the where the index is 3. So the beauty of this is sometimes this is easy. Let's say first 10 rows. So if you need first 10 columns, how do you do that? So we can say df2.iloc. Colon will give you everything. The first two rows, you can say 2. Or simply we can put it like this. I hope you remember this one. So ideally what we do here is we say, okay, we need everything. And here we say, I need the first two columns, right? Which is easy to select based on what you want to, get it. Not only that, actually, you can, put the index numbers as well. So let's say you want to select specific rows and the columns. So you can put them as lists. Okay. Thanks, Supun. So do you want me to go up? Right. So maybe I will start him from here. Right. So we were discussing about selecting data based on the labels. So this is multiple values. This is just one value. Then the second one based on the index, the position, right? Multiple values, a single value. So what we have discussed here is if you say df2.loc0, we select based on the row label. When row zeros, that's the information we get it here. Right. Hope you have finished up to this point. Yes. Okay. Let's move to the next one. Now, if you're wondering why we have zero here, because we didn't put a label. So I have another example here just to explain that one. So I have calculated, or I have put up two commands here. I created a new data frame 4, where I have created 3 by 3 matrix with the index labeled as ABC. That means the row labels. The columns we label as capital ABC. So that's what happens in the, and then when you visualize like this. Right, now in here, if you want to select the first row, now it's a label, right? So simply we can use df4.loc based on the label, we make the selection. Yes, how many of you finish up to this point? So I hope now you understood why we have put it in this way, right? And then, for example, here, why we have used. So for example, in this particular case, you will notice that I'm going to select everything and then first 2 columns. So since I have used LOC, what we call label base. So here we will say everything, and here we will specify what label I want to keep. So here we will say, okay, I want to keep all the rows, but here we will say, okay, we want to keep only A and B. Okay, can you confirm whether we have finished up to this point? Okay, let's move to the next one. Okay, for example, to answer the Dilanka's one previously, so this is preferred, like especially when you have a situation like this. So normally, normal access, you might not be able to access like this. And especially when you want to make filters, right? So this is very, very helpful. Right. So the next one we have discussed is, specific set of rows and specific set of columns. Please confirm whether you have finished up to this point. Right, done. Let's move on. So now we are discussing based on the position. So we use ILOC here. And when you say 3, it selects the third index. right? And we get value for each column A, B, C. Right. Let's move to the next one. So in this particular case, you will notice that we will say everything and then the first two columns. So in a way, this is very, very useful because you have now flexibility of selecting the rows and columns the way you want. So for example, let me give you one more example. I can say df2.iloc, and then I can say, okay, the row values 5, 10, 15 in index, and I need the first and the third columns. So you can notice that you can get part of the data like this. So you have a flexibility of accessing any data item the way you want. Right. Now this is LOC, and I also LOC is because you can actually access multiple values. But the same thing can be used to access just one value, right? So for example, let's say I'm getting a value. So simply I can say df2.iloc, let's say third row and the first column. So that is one way to get it, right? But when you have a huge data sets, data frames, the fast access would be using IAD because you're accessing just one value. So you will get the same answer, but if you prefer the fast access to individual values, make a note of that. You use IAT. Same one, but this will be fast access. Right. Now that we have discussed about viewing in various ways, I'm going to talk about filtering. Filtering means the dataset selection or data selection based on some conditions. Now you have noticed in DF2, our data frame, there are some positive and negative values. Yes, you might have noticed that there are some negative values as well. Now let's say that I'm interested in selecting positive values. And in this particular case, let's say I'm specifically interested in column A. So we can check this. So I can say like this. I can put it like this, df2 column A, right? I can put it like this. So this is inequality. And what happens there is we are simply checking the values of A. This is called Boolean indexing, and we did it with NumPy arrays as well. So you can see true, false values where we are asking whether it's true or false. But if you want to select only those values, we can say df2. Right. So now what happens? So it will select, you can notice, it will select the rows which are the values of A which are greater than 0 only. So you can notice now, if in the column A, everything is positive, right? So in that way, you can actually filter a data set based on the values or the based on the condition. So very interesting one. Right. Now, let me show you like one way to just ignore the negative values and keep only the positive values. Right. Now, here we said DF2A, we specifically focus on one particular column and we check whether the values are greater than 0. By the way, how many of you have finished up to this point? Okay, thanks. Which means that I can move on, right? Okay, so the next one. So in the next one, what I'm going to show you is if you just check the data frame, let's say this inequality and see what happens. So simply we will check every value in data frame, whether it's greater than 0, right? And if you want to select or if you want to create something where you need only the positive values, it be something like this. So if I use DF2 and if you to select, so you will notice that only positive values are remaining. The other values are, we call none, right? So here what it means, usually it says not a number, right? So simply the not a number, this nan will represent missing values, right? So ideally nan is available with the NumPy, pandas, and even the math module. So here nan means is missing because we have selected the values which are greater than 0. If the values are negative values, now it considers missing value, right? So hope that part is clear to you. Now what I'm going to do here. So assume that you have a data set with missing values. So how do you handle it? So I'm going to make use of the same thing here. So we have just some values and some missing values. We need to fill. So one way to handle the missing values is you can remove them. That is a straightforward one. If you if you think that, okay, missing values are problematic in your data set, simply you can remove them. So this is called dropping it. So let me show you how you are going to do that, right? So I'm going to say this is DF3. I'm going to create the data frame based on this one. I'm going to say DF3, right? And if you look at DF3, maybe I will say head. This is how it look like. So we have a data set, not a number. This represents some missing values, right? The next one, okay, now DF3, we have some missing values. We are going to discuss how to handle missing values. So handling missing values. First technique is you can remove them, right? First technique is handling missing values. The first one is you can drop them. So let's drop them. So I'm going to say this is data frame 4. I will get DF3 and I'm going to say drop NA and why, how is any meaning like if you have any missing value, you are going to drop them. So if you do that, if you run it, You will get set of rows like this, where we are without any missing values. So ideally we had 100 rows, and you can see we are getting only a couple of rows. If you do like this, right? This is one way to handle this. So we were discussing how to handle this. So when you just drop, what has happened, we are going to miss significant amount of data. So therefore, we are discussing ways of handling this. One way to handle is you fill missing value with 0. So we put 0, fill all the missing values with 0. This is one way. Then in your discussion, I have seen like you can fill with mean. Done, finish up to this point. We say df3, fill na value. So what we could do is, let's fill with mean. Same command, we can say df3, fill na. We can say value is df3.mean. And this is what will happen. Any missing value, we fill with the mean value. We calculate the mean of the column and we fill with mean. Now this is okay if we have numbers. What about if you have labels? Right? Sometimes the data which contains some label data, right? So we can't calculate any mean value. So if you have that situation, you can go for mode. That means most frequent value, right? So let me show you here as well. So the next one I'm going to use to discuss, okay, let's fill with mode. Mode means most frequent value. So how do you do that? We can say df3, right? And then we can say mode. But then again, when I say mode, right? So for example, we can say df3 mean. So how it look like is like this, mean values. Yes. But if you say mode, right? So you will have multiple values. So therefore, we have to select the 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 first value, most frequent one. So we need to select most frequent value. So therefore, when you are replacing, it's better you put this part as well, so that you will replace with the same value. Otherwise, you might see that it will be different. So make a note of this. So you fill with the mode, most frequent value. Right. I think what we have discussed so far, just to summarize, we discuss about what might happen when we have missing data. So we discuss how to replace missing values. You can remove columns with any missing value, or you can just replace with zero or mean and mode. So which one to use? It actually comes from the practice and also what you need, your require. Right. Now that we have discussed, a few things, I would like to, conclude our discussion by give you some operations, especially let's see how to calculate mean, and then we have looked at how to get the mean values. So for example, here we have already done this. So for example, df3, maybe we'll start with the df2. So let's say mean value. So we get mean, and then that will give you the mean for each column. But if you need like row wise, or you can say column wise, sorry, not row wise, the column wise. So we can say df2 dot mean, I can say axis is 1, right? So when I say axis is 1, so for each, you take the columns and then take the mean. So you will get the mean value. So this is called column wise mean value. So this is called row wise. That means we calculate, everything. We calculate the sum of the rows, divide by the number of rows, row wise. Here, what we did, column wise, calculate for each row, we calculate the total of the column, and then we divide by 3. In our case, we had 3, right? Yes. Right. So let me now discuss how you may actually access data in various different format and put into pandas. Now for that, I need some data points. So let me see, I can share you like some data points for you. Right. So first of all, let me explain how to use a CSV file. Right. So I'm going to share with you some data in the chat. You can actually download the file. Right. So this is, I have CSV file. Then I have Excel file. Right. Now, data that can be in various different forms, and what we discuss here is how you may actually use CSV files, and we can take them into our data frames. So let's see how we can actually read CSV files. First of all, you need to load the data set. Now, ideally, it should be in this, since we've been online, it'll be somewhere in the server itself. So ideally, we have to upload them, right? So therefore, you can click on this button, upload, and then you can select the file, right? You can actually select the file. So let me select the file for me. So I have some files. I'm going to select the weather CSV. So you can download the CSV file. And then if you upload, you can notice that now it is available. So this is in the local environment. So the command now, you can directly access the data. So for example, I'm going to say that this is df weather. I can say pd.read CSV. This is the function. And then I will type the file name. And if you run, you will get the outcome like this. Work on once you have the data set, you can do things. You can select rows like what we have discussed early. So for example, we can say select, okay, this is direct. I'm going to use Outlook, right? Or you can use df.outlook. Sorry, I said df. It should be df weather, right? So you select just the Outlook. And then let's say you need to see the counts. You can get value counts. Okay, so you can have 3 sunny, 5 rainy, and 4 overcast. You can even plot it. You can say, I'm going to have bar chart. So that's interesting. So for example, this is how you can actually visualize the data in this simple data set. So what I did is simply I select the Outlook attribute, convert it into counts, and then put it into a bar plot. So this is something that actually you can do. Right. Now, this is something that you can do, but only problem with this way of doing this is, so every time when you want to work with the data, you have to always upload the data set. So ideally, what I do is I will save my file in my drive. So let me show you what I did. So if I go to my drive, I have Colab notebooks and I have some data sets. Okay, so no, it's not my drive. My drive, we have Colab notebooks, right? And then we have data sets. And in the data set, I have this weather data set. You can notice here. I have many data sets. Hopefully the weather. Okay, so this is my weather data set, right? So likewise, you can upload this into your Google Drive. And then now I'm going to give you the code. How do you access your Google Drive? So let me show you how to do that. But before that, please upload this file in your Google Drive and make a note of the folder. So right now, in my case, I'm actually putting into my Colab Notebooks datasets folder. Right. Now let me show you how to do that. So what I'm going to do, uh, I'm going to explain how to read CSV file. Google Drive. Now the idea is every time if you're frequently accessing the data and uploading will consume some time. So you can do it through Google Drive. Okay. Right. So the code is like this. First of all, you need to mount Google Drive. The command for mounting Google Drive is usually you have Linux environment in these hosted ones. So you have to say from Google Colab import drive and then drive mount, and then you can provide the path, right? So depending on what you are going to do, maybe I will say Google Drive, I would G Drive here. So that part actually you can customize, and this will be appear here as well, right? So that you will notice that the mounting in here, right? So so now what happens? Okay, maybe I will have a separate here. I will show you the commands that Linux commands works here as well. For example, if you say ls, it says it will show you the files, the whether data set is right now it's available, and present working directory. So it's in content, right? So what I'm trying to do is I'm going to now put my drive here as well. So my Google Drive, I'm going to make it G Drive. So that's what I'm trying to do. So let me run this. So when I run this, you will observe that it asks me the permission to connect my Google Drive. And then I will select my account and I will give you authorization. Now they will access to my drive files. And this time, if you do that, right, it will take some time to connect your Google Drive. And now if you look at, it says mounted at content G drive. And if you run this, you will notice, right, we have content in G drive. So let me show you what we have inside ls list files. Now you have G drive as well. This was not there earlier, right? Now let me go inside the G drive. So you can start with the G drive, sorry, content, and then I will say G drive. So that means I'm going inside my Google Drive. It says my drive. So now I'm going to go inside my drive. And if I show you the file, you will see I have a lot of files. But I hope I have showed you where my files are. It's inside my drive, Colab Notebooks datasets. So I'm going inside the Colab Notebooks. So I have to say Colab Notebooks. So since I have a space here, I have to use a single quote to avoid this one. So maybe I will put it here. So I'll put Colab Notebook. Is it Colab Notebooks? Right, now let me run. Okay, you can see here. And inside that, I have datasets. So I will put datasets. Right. And there are a lot of datasets here, but if you look at carefully, my weather dataset is also inside here, right? So this is the folder, and you will notice. But if you want to just check whether it's available, I can directly type weather.csv. And you will notice that it's here, right? It's here, right? Now let me create a data frame based on this. So what I'm going to do is I'm going to say data frame 6, okay, td.read CSV. Now I'm giving you this complete path to file in my drive. And then if you say df6, so this time, let me say yes. So this time actually I have created the data frame from the file I have uploaded in my drive. So this way easy, because next time when you work it, you don't have to really upload again. So otherwise, if you just use upload, every time when you want to work with the data, you have to update. One last things, if you have successfully done this, the next one is I want to discuss uh, how to save. For example, here I can say df6. I can select only the Outlook attribute. So I can say Outlook. Yes, Outlook. So I'm going to say this is df7. So let's say I have done some changes, and this is a new one, right? So you can see it's Outlook. So if you want to save, let's say this one as a new data, file. So what you can do is you can say to CSV if you want to save it as a CSV file. And then you can provide maybe outlook.csv, and then you can run it. And what happens in this one, I have put locally the file. So you can see Outlook CSV, and the Outlook CSV contains only the attribute Outlook. So this is how you may save CSV. Now, same thing can be applied for Excel file. The difference is instead of CSV, use Excel, right? So for example, so I'm going to read Excel. So you can use Excel file. So let me see whether I have Excel files here as well with the Excel. No, not here. Maybe I can upload it. So I have let me put it here as well, Excel file. So we have with the Excel. Okay, we have uploaded. Okay, now we have with the Excel in the Google Drive. So let me change the same thing. So I'm going to say DF8. I'm going to say read Excel. So read, it should be the way around, not XLX, it should be Excel, right? And then we have where the extension is XLSX. So let's see, it works. Okay, works fine. So let me, if you want to make changes and if you want to save it with a new name, then you say to Excel, right? You say to Excel, read Excel and to Excel. The CSV, like CSV, you can use that. Right. I think those are the points that I want to cover with pandas. I hope you got an idea about the capabilities available for pandas. And in this session, we also discuss how pandas could be used to create series data frames and also manipulating data frames, and then also accessing various files. I just cover only reading CSV and Excel, but then there are other formats as well. For example, you can read text from web pages. There's a command called read HTML. You can explore that. So you can read it from web pages and you can put it to, data frame as well. With that said, we can finish up to this point, and next week we can move on, talk about more on applying the modules that we have discussed so far.